Hello, this is Jack Jackson back, and we're going to continue our talk about combinatorics, and specifically we're going to continue our discussion of the combination, or binomial coefficient as it's sometimes known. And we're going to see how these numbers show up in something that's called Pascal's triangle. Actually, it's named after Blaise Pascal, an important mathematician who, among other things, was very important in the early study of probability. And it turns out we get a nice little recursive formula here that's going to lead to the creation of Pascal's triangle and going to lead to the creation of these combinations or binomial coefficients. So it turns out one way you can find n choose k is to do n minus 1 choose k minus 1 plus n minus 1 choose k, and to add those two together you'll get n choose k. Now we're going to I'll show you the derivation of the proof of this, and then I'll show you how it shows up in Pascal's triangle. So warning, there's some algebra here, okay? But there's not much. It's really just, it's a lot of symbols, but it's just what's mainly used is getting a common denominator and adding these up. So by definition, the factorial definitions, n minus 1 choose k minus 1 is n minus 1 factorial over n minus 1 minus parentheses k minus 1, and factorial all that, over and also on the bottom k minus 1 factorial. And again, by definition, n minus 1 choose k is n minus 1 factorial over n minus 1 minus k factorial, k factorial. Okay? So let's see, this is n minus 1 minus k plus 1. Well, the 1's cancel, and so this is just n minus k factorial here. Simplifying that a little bit. And then this is n minus k minus 1 factorial. Okay, so we need a common denominator. Well, this has factors, this k minus 1 factorials is 1 up to k minus 1. And the k goes one more factor than that. It adds or multiplies by another k. So I need to multiply this one over here, top and bottom, by another k. And then it will bring this k times k minus 1 factorial will bring it up to k factorial. Similarly, this is n minus k factorial. This is n minus k minus 1 factorial. This one on the left has one more factor. So I need to multiply the numerator and denominator, the one on the right, by n minus k. And then what happens is this part right here becomes n minus k factorial, and this part right here becomes just k factorial. So now I have the same denominator. I can keep that denominator and add the numerators. Now I'm going to factor out some stuff using the distributive property. I'm going to factor out the n minus 1 factorial. And that leaves, what does that leave? That leaves a k plus n minus k. Well, the k's cancel, leaving that to be n. And n times n minus 1 factorial is n factorial. And that is exactly the definition of n choose k. Okay, so hopefully you followed that. There's a lot of symbols going around there. But basically what's going on really is just getting a common denominator, adding, and when it collapses, it ends up giving you what you want. Now we can see this, I want to show you in Pascal's triangle. So we also have a couple of different special cases that we've actually looked at in our last video. N choose 0 or n choose n, either one is just 1. N choose 1 or n choose n minus 1 is always just n. And then there's our recursive relationship. So if we set up a tree like this, a triangle like this, we start with 0 choose 0, which is just 1. 1 choose 0 and 1 choose 1 is also 1. In fact, all of these on the outside are something choose 0, so they're all 1s on this first number in the row. The last number in the row is always n choose n, and it's also 1. Now to get from one to the next in the row, we use this recursive version. Let's say to get to the 3 choose 1, what that says is you back up to the n minus 1 row, so you back up 1 row, you do one at the same place you are in the one before and add them. So we're at the first position. Remember, you start counting at the 0th position. So the first position is we back up 1 row, take the one at the 0th position and 1 position, add them together. So 3 choose 1 is 2 choose 0 plus 2 choose 1. So add those two together to get this. Now let's do it with actual numbers in. I think it'll make more sense for you. So the way this works is Pascal's triangle. It starts with a 1 and then 2 1s. And then you bring down the 1 here and here, and you add the 1 and the 1 to get the 2 here. Next row, bring down the 1 and the 1 on the end. 1 plus 2 is the 3 here. 2 plus 1 is the 3 here. Next row, always starts and ends with 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Bring down the 1. Let's do another row. 1, then 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5, and you end with the 1. And so forth. You can see this all the way down. All right, so here's a question for you. Figure out what the next row is. Well, it's 1, 11, plus 10. 10 plus 45, so it'll be 55. 45 plus 120 is 165. 120 plus 210 is 330. 210 plus 252 is 462. And then it starts working its way back down, the next one being 462, and so forth all the way down. Okay, so this triangle on the right and the triangle on the left are the exact same triangle. So these numbers in this triangle are these combination numbers, also known as binomial coefficients, because they're the coefficients that show up in the binomial theorem that you may I actually talk about the binomial theorem a bit more in one of my algebra videos if you're interested in pursuing that.